This is a demonstration of the technology developed in NetAlign, a small technology-focused startup that I co-founded in 2008. NetAlign specializes in data mining algorithms in unstructured textual environments, of the kind found in social networks, blogs, and online forums. We have developed fast algorithms that make the data on such a network accessible for a large set of applications. The analysis we'll see here is made on the public data available on the social network created around the ICQ chat client. The dataset includes all user interactions made on the network during 2008. We have processed 219,000 interactions made by 57,000 users. These include 65,000 forums and blog pages and 145,000 comments. We know that about 500,000 unique users have visited the site during this year, with large groups from Germany and Russia. We did not have access to internal data such as traffic logs, IP addresses, friends lists, and private chats. Having access to such internal data can improve the accuracy of the algorithms significantly. The first application is the page clearance for ads. We'll demonstrate how you can classify pages that include spam, profanity, adult content, and extreme slang as dirty pages. Without such a clearance measure, brand names would probably consider such a social network to be inappropriate for ad placement. With this measure, many of the page views become a valuable asset. Moving into our first analysis tool, we see here a schematic view of the social network's forum structure. I'll drill down into the music forum, then into the hip-hop and into Eminem Fan Center, a popular singer fans forum. We now see the titles of the pages in this forum. Those pages that the engine has classified as dirty are marked in red. It's easy to spot those nude girls and Asian fetish posts that are classified as adult content related. But let's look deeper into why this good Eminem site and news page is marked as red. Drilling down to the page text, we see that this is some sort of a message about Jesus' arrival in 2015. So this is not simple spam, and there's no profanity here. What we can see on the right-hand side is that the post was identified as unrelated to the content in nearby pages and was thus marked as suspicious. We are seeing here the strength of this context-aware algorithm. The second application is automatic topical categorization of a single post. As noted before, we are looking here at a musician fan page. Switching the filter to the music topic, we'll now see those pages that are ranking high as music-related. The stronger the blue color is, the higher the post is scoring on the topic. Let's look at one of those pages scoring high on music. It seems to be a list of names of songs from one of those musicians' albums. Although the text itself does not immediately suggest that this is music-related, the algorithm has seen those song names elsewhere on the forum and now associates them as being music-related. The third application is an analysis of a page holding several user posts and comments. We'll see how we automatically classify the page category and extract main textual concepts or keywords. These can be fed, for instance, into an ad server to receive contextually aware ads. I'm now navigating to the travel area of the social network and setting the coloring filter to color the travel topic. I'm selecting a page and going into the first post on this page. We can see that the writer is asking for advice on traveling to Belgium and the Netherlands. This post is clearly classified as travel-related. I'm now requesting a report on the full page with this post and the responses. Let's see some of the features we've got in this report. We have analyzed 6 messages in the page. The topics found are mainly travel, with some relation to lifestyle and romance. The keywords scoring highest are Cologne, Amsterdam, Belgium, and Netherlands. You can imagine what ads will show up on this page when the ad server is fed with these topics and keywords. The next application is building a profile of a user that is using the social network. We'll try to answer the questions of what the user's main interests are, and his or her age group and gender. I'll build a profile on the user Carol from the previous example. We can see that we have analyzed 21 user interactions on the forum, including 5 blog posts and 13 messages to other users between January and August. We've seen this user posting on the travel forum, but he or she has been active on pages about physics and wildlife too. The user's freestyle text posted on the forum was classified as related to news, music, and adult-related. The engine has classified Carol to be, most likely, a female from France. From her language style, it has classified her to be around the age of 25. Very accurate. We'll now see how the technology can be applied to automatically put some order in the blogosphere, where the lack of hierarchical topical structure makes it hard for people, as well as textual analysis engines, to find the meaning of things. I'll navigate here to the open blog section of the network. There are thousands of blogs here. I'll zoom into Dave's blog. Again, marked in blue for scoring high on travel category. Dave is blogging about his experience in the Czech Republic. Then he posts another blog entry about his travels in Croatia, and another post about his eating experience while abroad. Those are all classified correctly as mostly travel-related. Fine. Let's look at how we profile Dave's user. In his 22 interactions, he had mostly placed blog posts. His topics are mainly classified as related to news and travel, but he has also interacted in the rock music fan page. The keywords scoring highest for Dave are Poland, Republic, Hotel, Castle. Although we did not identify his country of origin and his age, we did identify 3 of his interactions to be in German. Let's see one of those German interactions. One sentence is enough. The next section of this demo is about making sense of the social graph. People communicating with each other tend to have similar topical interests, age group, and country of origin. Clustering the social graph means that we can associate users whom we know very little about to users that are clearly classified. This gives us a lot of power. Moving to see our second analysis tool. On the left-hand side, we see the interactions graph unclustered. Each user is a node and each interaction is a vertex. The first thing we clearly see is that there are just a few users that are the hubs of information, linking to many other users. These are the mavens of the community. We would like to target them as they are the most influential individuals. In the middle, we see a graphical representation of the clustering done. Not all users can be grouped, but most can and get into tight groups of a few hundred users each. Let's see what we can derive from the clustering. We'll color the users according to their age group. The cluster on the left side shows us a group of users. Many of them are in the age group of 35 to 55, marked in red and blue. Although we didn't have a clear classification of many other cluster members, marked in gray, we can conclude they are most likely of the same age group as well. In the center part of the screen, we open a topical summary of this cluster talks. We can see that in each category, there is a clear lead. This group of people is talking only in the World News Forum. They only speak English, and their messages are classified as news-related. Thank you for watching this demo. You are welcome to comment, ask questions, and connect with me for details on how the technology was created and what algorithms we have developed for unstructured text processing and community analysis. Sadly, nothing came out of this startup, but it was a fun experience nevertheless.